attempt number 2 to try and capture game states, or 3 depending on how you wish to count. But working with the game states, the key thing to keep in mind here is it really is about understanding the program flow. How does the program flow? Line by line. And we're not saying line by line in terms of line number 1, line number 2, line number 3, but once I go through a line in my program, where do I go next? Or where do I get trapped until something happens, some event occurs, and then where does it send me after that? So it's being aware of the flow of your program. And if game states are giving you trouble, it's invariably because you're not tracking accurately where your program is sending you after each line. So first off, right now I am in the super simple game state file, and we can see got a few variables up here. I have a ball object, I have a game state, and I'm using a string because then I can set game state equal to words. These words are then easy to keep track of. Using all capitals for the names of the game state. So then when you're looking through the code, it stands out. It's easier to see that way. So the preference is to set up the value of the game state with all capital letters so that we can read it faster. So we got some variables up here, have some text, have my score that I'm keeping track of so as my game runs. Now, like every program that you write in processing, after the variables are loaded, or the variables aren't really loaded, they're instantiated. We're setting aside memory for these things. But if you notice, none of them have a value yet. The ball doesn't have a value, game state doesn't have a value, my strings and score don't have values yet. We assign the value when we need them. And it's a common practice not to assign the value in the beginning, but you assign the value in a more logical place in your code because then it can make more sense working with it. Now, in processing, the first function that runs is going to be the setup function. So we create our variables, then setup runs, and then after setup runs, anything that's called in setup will run immediately and run a single time. And then the draw function runs, and the draw function will then keep running until the program is shut down. So that is our enter frame, that is our loop, that is our continual running item, the item that is tied to frame rate. So draw will then just keep looping. So under setup, does the size, sets the size, sets background color to white, calls the smooth function so that all of the primitive objects that we draw have a nice smooth, clean appearance. Otherwise they look kind of, well, they're aliased and ugly. So at least that makes them look a little bit better. And then we assign a value to our game state variable. So lines 1 through 16, instantiate our variables, get our sketch, our program organized with its basic parameters, and then sets the game state variable. And that's all it does. Now, if we look at the draw function, it calls clear background, and that now just fills the background with white. Again, it's good to have your background clearing in its own function, because if we didn't want to just fill the background with white, perhaps we wanted to fill the background with an image. We wanted to fill the background with a transparent rectangle. We wanted to do any number of things. By having it separated into its own function, it's easy to control and manage. And then the draw function is going to update objects and update the user interface. So when we look at what is going on at that point, we can see that we will come back to update objects, but updating the user interface, it assigns a value to status text, and it says gameState is, and then it prints out whatever that gameState variable's current value is. Takes the score text variable and then prints out score plus whatever the score currently is. Now, score does not get a value until I press the mouse. So when we look here, we can see clear background, update objects, update UI. If I run this again, we can see some text has appeared. There's no ball moving around. The red ball is not bouncing on screen yet. But now we have text appearing here under gameState, and under UI we have our status text or score text. We set the fill color, and then we specify that we want to see these text items appear on screen. Now, if you want more background information or understanding of using the text object in processing, go look up in the help file. It has really good explanations, really good instructions. You just assign a value to a text variable, set the fill color for the text, then you call using the text function, and then you specify what you want, what text you want to show on screen, and where you want it. That's all it takes for showing text, not hard. Later on we'll look at how to then attach fonts to your project, so you can actually have more than the default typeface that shows up, but you can actually create fonts from any font that you have on your computer or download, and then include the font metrics, the font data with your project, and then load text with that font. So we will cover that workflow, but that's not on today's agenda. Now, the mouse press function is waiting for us to press the mouse. Now that mouse press function is going to run independent of the draw function. So we don't have draw saying, hey, did you press the mouse, and querying that every time, because the mouse pressed is a function that is kind of at the core level in processing, so it's always looking for, can find, and work with being pressed, and it will then trigger off on that event. The same way that we can have a key pressed function, we can have a mouse pressed function. So with mouse pressed, it says, hey, if the game state is start, or if the game state is over, so if it's one of those two situations, creates a new ball, sets the score to 0, and then changes our game state to play. Let's go back to draw again. Draw every frame, calls clear background, it calls update objects, update UI. Well, the update UI, it's going to always show whatever the current state of the game is. It's going to show whatever our score is, and then print that text out. But update objects is where the real magic is happening. The game state is start. Instructions text has all of these values. The /n that we see here puts a line return, so that allows these lines of text to show up on separate lines. Putting two /n's allows me to put an extra empty line between two lines of text. So I did it in this format using the plus equals on instruction text. So instructions text and then is equal to whatever it was before, plus this new stuff, plus the new stuff, plus the new stuff, so that when we look at the code here, it doesn't wrap all the way, 3 monitors wide or something like that. So it just makes it easier to read. I could have said instructions text is equal to and then just put it all onto one line, but I think this is a little bit easier to read. So I would encourage this formatting. So if game status start sets instruction text, but it doesn't do anything about the ball. It doesn't create a ball. The ball doesn't get created until I press the mouse. So my game under update objects, when the game status start, all it's doing is showing text. And that's it. It's just showing text. The moment I press the mouse, game state changes to play. So that next time through my draw loop, after I've pressed the mouse, update objects encounters a different situation. When the game state is now play, so it's become play, instruction text becomes empty, so it goes away. And now I've put a few comments in here. Put your game logic here in between these comment tags here. Ball update, ball display. Because this particular game only needs those, that's all it takes. All it's doing is a single ball telling that single ball to update and display. If I were using my catcher game, that's where I would be telling the catcher to update and display. And then I would be looping through my ball array or my drop array and telling every raindrop to update and every raindrop to display. But here, because we only have a single object, we don't need to go into that complexity. So it tells the ball to update and display, then the ball moves. Now if we look at the ball, after it's created, it has an update function, it has its display function. Under its update function, it queries and says, hey, did I hit the left or right margin? If so, change game state. So it just checks for that. But if I hit the top or bottom margin, it just changes its direction and adds to my score. Display just simply draws it on screen. So when it does hit the end margin, game state switches from play, game state becomes over. Now instruction text becomes changed to ready to try again. And then if we look at mouse pressed, well, notice mouse pressed while the game is playing is not going to register, because mouse pressed while the event is occurring, my code is only looking for mouse presses when the game state is either start or over. But when the game state is play, mouse pressed isn't going to do diddly squat, because I don't have anything happening when game state is play if I press the mouse. So I can press the mouse the whole time the game is running and nothing will happen. Nothing will occur, because my mouse press function only runs and does something when the game state is start or when the game state is over. So after the game is over, creates a new ball, sets my score back to 0, sets the game state back to play, and then my game is up and running again. So in gameStates, simple, it has a few extra things, a few bonus features built into it. You can win and lose, which is nice, instead of just ending with over. So the super simple just had start, play, and over as our possible game states. But since many people are competitive, they enjoy being able to win and lose, keeping track of that, not just having a score. You could even have a high score, so it could always maintain whatever the high score is, and it could print out the high score on your as part of your user interface. So it could show you as you play through multiple games what is your highest score that you've currently achieved. So we could add in that. All of these things are just additional features that require you just to set some variables, track those variables, and then integrate them into the project. But it shouldn't be based on what you have running so far. Adding in something like, what is the current game session's highest score achieved? Because we're not saving the high score on the computer. We're not putting it onto a server where we can track it. But if we just want to if we play the game 5 times, what was the highest score we achieved during those 5 games? That would be something that we could very easily integrate or track into the project. So we could fit that into it. We can fit into it then also tracking or integrating levels, which makes it more fun. So instead of just win or lose, it's either lose or continue, where you continue until you lose type of thing. But then that requires some thinking about what are the situations for how do we actually lose and how do we do it. And your catcher game is set up more for adding levels to it than this particular example. So first we'll start out and do the current session high score and track that to show that we can add in an additional value into it. And then we will look at how to integrate some of the leveling feature into the game. So, string of highest score, and then we'll have a high score value. So those two we can now pair and put on screen. So as part of the UI, then highest score will be equal to so we will highest score text will be high score plus then the high score value, and then we just need to put that on screen. I'll just put it down here, but it's text highest score, and its location we'll drop it right below score. So if score has a left hand or an X position of 50, we'll maintain that, and then put it at 160 Y, so it's down below. So that now shows us the highest score. So if we run the game, we'll see that current high score is 0. Now one thing that you will notice, score does not get a value until load game is called. But if we look here, setup is run, and then that puts our game state to init. Clear background, update objects. Update objects doesn't set the score. Update UI, well, score and high score have never been assigned a value. But score gets a value at load game, which doesn't happen until after I press the mouse. But what processing is doing, and this was inadvertent laziness on my part, processing is saying, oh, those are numbers, integers, and if you don't assign them a value, it's defaulting their value in the beginning to 0. So it's giving them a default value of 0, which is because otherwise, technically, I should be getting an error message because the first time update UI is called, score and high score have never been assigned a value. They don't have a value assigned to them. All they are is just an empty integer variable. So technically, I realized as I'm looking at the code today that I goofed. Inadvertent laziness, I took advantage of the programs automatically defaulting their starting value to 0 because I didn't specify otherwise. In many other languages, I would have got an error message about trying to display something that is undefined or null, that doesn't actually have, because high score, nowhere in my code have I said high score is equal to 0. Yet when I run my project, it comes up and says high score is 0. So it's assigning a default value even though I through inadvertent laziness, forgot to do so. So shame on me, bad form, and we probably should give it some value.
Quick question, when you're using the...
So what I could do is correct for my laziness here and say assign a value to score of 0, assign a value to high score. So they both have explicitly assigned starting values. I should never rely on it just defaulting it with content. And in every other programming environment, it probably would have generated an error message about you're trying to use something before it's been defined. It would just, or it would just print out high score null. And then I click, and then it says 0, and then be like, oh, there it is. All right. So now we have our score. We have our high score here. Now, what we need to do is to look at now in the game change options here and what causes things to happen.
I've got a quick question.
I'm going to rename to try and cut down on confusion. I'm going to change. I will have high score text and high score to try and maintain consistency between things, but also to make it easier to keep track of. So there's the text of the high score, and then there's the number value for the high score. So we have the high score text, and then we have the actual whatever the high score is going to be. The first time our game runs, we assign high score value of 0. Then what we need to do is to compare every time the game is won or lost. We need to find out, did we achieve a higher score? If so, high score will change its value. Now, the changing of the state is occurring when I hit the margins, when x is less than 0 or x is greater than the width. Score is going up when I hit top or bottom. That's how this simple game is set up. When I hit top or bottom, I get a score. If I hit the sides, it's game over. So before we kill game over at that point, what we can do, and there's no reason to change x because the game's over at that point, so we don't need that. But what we can do before we do that is if high score is less than score, high score is equal to score. So if my current high score is less than the score I just achieved, we will set high score equal to that new score. If I run it, highest score. Oh, well, that's ugly looking there. Let me just fix that. It's high score. High score is 0. High score is still 0. Score is 1. Now my high score is 1. Now if I play again, oh, this one's going to go on all day long, but I'm going to achieve a remarkably better high score and much better than my 6 loser games in a row that I started the class with. So you can see as it's running, my score is going up, my game state is play, high score is 1. So all of that information that we see here, 17, 18, wow, might even break 20. And now my high score is 21. Now when I play again, high score is still 21. So it's going to take a long time. So I scored 2, but my high score is still 21. So we're able to now track that over the course of the game. And the key thing is keeping track of these game states and what is changing and where. So to add in a basic level concept into this, what we need to do is we need to have a level value, and we need to then change that level value when a certain condition has been reached, some type of level completion, previously say when, and then from there we need to be able to set it up so that we can make our objects behave a little bit differently. So we need a level value. We need to make our objects respond based on that level value. So in this instance, our ball object has a speed x and a speed y. So we want its speed x and speed y to be modified by the value of the level. The value of whatever that level of the game is. So to do that, we need to have a level value. And we'll define the same place we defined our initial setting values for score and high score. I will define level here as well. And level will start out at 1. Now, I think I want to see the level on screen. So we will have a level text as well. Level text is equal to level So put the level text on screen. Okay, so level starts out at 1. If we run the game, we should see now the level text. And as always, if you notice, I haven't done any logic with it. All I did was prove that I can see it on screen. This is not a bad course of action. Meaning, if we add something to an existing program, don't add tons and tons and tons and tons and tons of crap, run it, and then watch it fail, give you error messages and other problems. Add a little bit, run it. Add a little bit, run it. Make sure things are working. If you put a ton of stuff in, then you don't know what broke it when it breaks. So just put a little bit in at a time and work with it that way. Okay, so currently we're able to track the level. I don't have any way to change the levels, but I want the level to change every time I get a new high score. So when my high score is less than the current score, so that I set a new high score, we will also say level. And I could just say plus plus if we want to go up by 1, or I could say level plus equals 1. Doesn't really matter. If I want level to go up by 2, so it goes 1, 3, 5, we could do that. We could make the level double, so we could times equals 2. So every time we go up, it goes 2, and then it becomes 4, then it becomes 8. So we would see a pretty remarkable change every time I hit a new high score, which could be kind of fun. But we'll just go up by 1. And actually, to make it more dramatic so we can see the change faster, I'm going to make my level, we go up by 10, so it'll be 1, and then it'll be 10. Or, I'm going to times it, though. No, that won't do it. So if we go up, now, what I want to do is when I create a new ball, I want to tell that ball what is the current level. So we're going to pass a parameter, because currently the object, so this is your drop objects that you have, those drops that are coming down. If we want them to behave different based on the level of the game, we probably need to give them knowledge of what is that level. So we need to tell them. So when I create a new drop, I want to pass to it whatever the current level is. And now we need to append our constructor. Was it? It was an integer, okay. So we're going to accept when the ball is created what that level is, but we will take its speed and we will times it by the level. So we are passing in I'm just going to, though, name it, thank you, and get rid of that extra L there. I don't want to use the same variable that's defined in the main game. I want it to be so it's not grabbing the wrong value. So all right, so we're passing in a value, we're timesing it here. So now what's going to happen is every time I set a new high score, level goes up by 10. That means the next object, instead of having a possible speed of -5 and 5, it now has a speed, when we go up a level, of -50 to 50, which means we could get a really fast moving object. So the first time through, it's level 1. Okay, now we're at a level 11. And you saw, yeah, really, I want to get a new high score so we can see it really go fast. Oh yeah, now we're really, so we can see that it's really taking off. Because now it's 21 times 5, so they can move over 100 pixels per frame, possibly. So yeah, it's pretty bad. So we've proven it works, but going up by 10 on our levels isn't going to give us a really great amount. But if our level just goes up by 1, but then if we wanted it to be, so it's somewhat appreciable or noticeable, maybe it's level times 2. And on your project, it might be level times something like 1.2. That might be the magic amount. So it's not just the level, but it's level plus a little bit more to get that ideal amount, because it may be you go up and you're like, well, just timesing it by, you know, the level, okay, that's too much, but maybe it's adding the level, or adding the level times 2, or adding the level times 1.2. And this is the challenge of figuring out how to integrate that kind of, that fine-tuning the values so then you get that proper user experience. You're trying to give a gameplay experience where things move at the correct speed, behave at the correct speed, and make it enjoyable to play.